Hello and welcome to Chapter 5. This is Module 4, and we're going to go through the lecture and PowerPoint presentation for Chapter 5. As I said in the introduction video, this week in this module is about electronic distance measurements and electronic collection of data and the introduction of the theodolite and total station. What changes from the things that we've looked at already? We were looking at some manual ways to measure distances, and that being with a chain, or even with a stadia rod, you can you can get a distance measurement that's fairly accurate. But now we're talking about some higher precision, and we're talking about much faster return of measurement and much more accurate. So while a chain can be pretty accurate for short distances, while a chain can be accurate for flatter ground, when you're dealing with a hillside or long distances, electronic measurement is definitely the way to go. It is much better, as we'll see throughout this chapter and the couple to come. One of the aspects is, think about the things that we can do. As I mentioned in the intro video, we can shoot across the water now. Before, it was kind of hard for a man to go out in the middle of the water and take a measurement and then keep going to the other side. So it's a better tool, and it's a more modern instrument, and it continues to just get better and better. The product gets better and better. So I'm going to go ahead and share my screen, and we'll run through these PowerPoint slides. And let's see here. All right, so now we're sharing the screen. All right, let's see. All right, so electronic survey measurement. We've already talked about that EDM is what's going to be referred to as an electronic distance measurement. We also are now looking at electronic angle measurements that are in your total stations. The main thing is to understand what's going on is that we're moving from a manual instrument to an electronic instrument that is capable of measuring distances and angles. The EDM instruments, they have a multitude of ways to measure. I never was around one that used a microwave. However, I have used the early electronic distance measurements were infrared. Today they are lasers. For some time they've been lasers, and they're pretty much very accurate than how they work. And as the book talks about, they measure over a wavelength. So the light that's emitted from the instrument, the signal, has a known wavelength, and that wavelength will travel at a certain speed. It will then bounce off and return. And the time it takes for it to return is how the instrument calculates the distance that something has traveled. And it can do this in a matter of a second or so to upwards of maybe 10 seconds or something for a distance that's further away. So much faster, you think, than a chain. That's for certain. The chain could take you, if you're trying to measure 200 feet with the chain, it might take you, well, one man has to walk down there just like you would with a reflector and an instrument, but pulling the chain and trying to get a good steady measurement could take a couple minutes. And now you can walk down somewhere 200 feet, take a shot, and get the answer in a couple seconds. So much more powerful instrument. This is a picture of a theodolite. It's electronic theodolite. It will measure distances. I'm sorry, it will measure angles electronically, but no distance measurement with it. Actually, I'm sorry, it says it's a total station, but the distance measurement is built in down here, and I thought it was a theodolite. So total stations will As the slide shows and the book tells you, total stations will actually measure angles and distances and collect the data all in one time. That's what a total station is. I'm not too concerned here about the wavelengths and you figuring things out. You can read through it. I don't think we'll test you on any of that. And that's why I'm not too worried about this part of it here. Nope. Do know that atmosphere has an effect on everything. So what I do want to talk to you about before we get into all these different prisms is the EDM's characteristics. EDMs shoot to a prism, generally shoot to a prism or a reflector. And in doing so, it becomes pretty accurate on the other end. I mean, really accurate, as a matter of fact. So the distance ranges, the book tells you from 800 meters to 1 kilometer. You're talking, what, 800 meters is roughly a half a mile. Yeah, no, 400 meters is around the track. Yeah, so it's roughly a half a mile to about 0.6 miles. You can go further than that with today's technology. And especially if you put multiple reflectors together, you can actually have a target that has 3 reflectors on it. And that is enables you to shoot for greater distances. But I have equipment that has no problem shooting at 3,000 feet, 0.6 miles, and there's other equipment that can go further. We can easily shoot close to a mile anymore with with the reflector. So just to point out that it would take you forever to pull a chain and go 3,000 feet. Now, with the single push of a button and a target on the other end, we can get a distance in a matter of 5 to 10 seconds at 3,000 feet away. Tremendous advantage. So the prisms, as you will notice here, in the book talks about them, they have different accuracies and different types, but they're all a piece of glass. There's some sort of glass that have some curvature to the glass and will point the signal to the center of the target. So wherever things are being collected, and I can probably do a little zooming here and get to a point. So right here, you have this glass. This is glass. You have these hairs on the inside that you can look at through the instrument. And the way this works is as things bounce off and touch this glass and signals sort of bounce and reflect on the inside, it always bounces you back off the center, which has a measurement straight over top of the center of the target down here, which connects usually to a pole or some sort of, they're called tribrax. It's a block that will attach the prism to it and sit on top of a tripod. Very similar to the picture on page 112, figure 5.7. So, but that's what prisms look like. They haven't changed much in technology. They've gotten a little more accurate and a little more consistent over the years. Here's the picture I was telling you about that's in your book. This is a person, he's got a bipod. This is 2 legs. You can see he's got his thumb right there on the buttons for the bipod. These parts here extend up and it's attached to a pole. These are called range poles. And here's your target right up there. It is screwed on to the range pole, and he is putting this on the ground at a specific point he wants to measure, levels it up, has it nice and straight, takes a measurement with the transit or total station. So what's some of the other things that we're talking about here? This right here is an old total station. It's something that's capable of without a reflector, measurement without a reflector. So what happens is that newer technology now, which I have had the opportunity to use, and it is quite beneficial. You can shoot the instrument. It will bounce off of something and come back, and that something can be anything. A white house is better than the dark pavement on a road. So light colors reflect more than dark colors. You can shoot, but you can shoot within reasonable accuracy, and I do mean, like an inch or so in 800 feet, which is reasonable. You could shoot telephone poles, sides of buildings. The closer you are, the more accurate it is. It can be within a quarter inch at 100 feet. That type of accuracy is really nice, and yet you can do it without a person on the other end. It doesn't work for measuring to control points or property corners or things like that. But for features like a big tree, telephone poles, fire hydrants, even the center of the road. Imagine being out on 301 or 95 and being told you have to locate the pink stripes on the road. Well, you can do that without stepping foot on the road. You can do it from the side someplace. So it has its advantages and its abilities to save time again, and as well as create a safer environment for the surveyor to work in. Because believe me, I've never been out on 695, but I have been on 301 locating the road, and I've been on 235 locating the road in St. Mary's right in the middle of traffic. Constantly having to dodge traffic and move around and wait for a little break and run out there real fast and do your job. So this type of slide shows where you could measure something where it's just bouncing off of the surface. This looks like some kind of a tunnel entrance, and this looks like, say, like the edges of a tank, so you can get the shape of it. So reflectorless is a good way to go as far as a lot of things today. It costs a little bit more money for your instrument to be able to do that, but it works well depending on your application. There's nothing more accurate though than the prism and the ability to shoot a prism over a point and know exactly where something is within the tolerance of your instrument. And most of the time that tolerance is something in the hundredth of a foot or less. And so there you're talking about something less than an eighth of an inch. So we'll stop the sharing. And here we are, we come back now to just me. And so that's the end of chapter 5. These chapters 5, 6, and 7 will be very quick. Take a break, but I'll be right back with chapter 6.